Hi, this is Fry. It is October 17th, 2017. This is a webinar on debugging. We are going to use Dexter Development Environment version 2.1.8. First thing we need to do is define debugging. Well, it's getting rid of bugs, of course, but what's a bug? Some people would say it's unexpected behavior from a user's perspective. Now, that's kind of loose, but from a programmer's perspective, where we're coming from today, it's really what the programmer didn't intend. So another euphemism is undocumented feature, but in any case, it's a mistake that you want to avoid. You want to avoid it because about half of programmers' time is spent in debugging. So this is a pretty significant hunk of your hours, and there's a big opportunity cost there with bugs. Now, we want to talk both about debugging and about how to avoid creating bugs. So there's strategies that programmers can use, and we'll be covering some of those. Programming might be divided into two successive sessions, a design and an implementation phase. But really, they shouldn't be so separate because there's design at all levels of implementation. We're talking architecture down to nitpicking things of function calls, and even formatting your text can make a big difference in understanding the code. Now, for implementation, we might talk about two successive sections, writing and debugging. But again, whether you're writing or debugging or doing some combination, there really should be very intermixed. If you attempt to write a whole bunch of code and then start debugging, it's going to be a much more painful and lengthy process than if you debug in the middle of your writing, in the middle of your implementation. How do you do that? Well, formatting a modular approach to ordering what you implement and then letting you test a small amount of code at a time. If you know that your bug is within a small amount of code, it is much easier to find than in a large amount of code. So we recommend a strategy of just writing a little bit, maybe only one function call or line or two, and then testing it. DDE encourages this by its select and eval, and we'll talk about that in just a minute. But you might think of, well, how would I order my code? What's the right strategy, especially if you haven't even designed everything yet, and you're starting to implement it. I do recommend starting to implement without completely design everything, but the important thing is, what do you start to implement? And that is probably best the very core of your code, the very core, the secret sauce of the algorithm. Do that first. That helps you know, can this thing fly? And then test it and see, okay, looks like it basically can work, without the bells and whistles, without the user interface, without good library design. Just get something to work. And by doing that, you might say, gee, this is never going to work, and you don't implement anything, and then you've saved yourself 90% of the work, because when you combine UI design and testing and good library design, that's really where the bulk of the work is. It's in this wrapper code. So do the core first, and then try to figure out how to modularize this wrapper code, implementing a button at a time, a menu item, a few simple widgets, and build them up. Okay, that's not to say that you don't want to have a good architecture, but you got to be careful, because trying to architect everything all at once is fraught with peril when we're dealing with complexity, and that's what programming is all about. Okay, now, essentially, the bad news on debugging is there aren't really any huge shortcuts. The key is understanding your code. If you don't understand your code, you're in bad shape no matter what. It's going to be hard to debug, hard to extend, hard to explain to other people, and probably won't work in the first place. All right, now, there's a certain number of bugs that are really common. And it's actually good for you to have these in mind because you see common bugs and those are the first thing to guess at where your bug is. So these might fall into two categories: syntactic bugs and semantic bugs. On the syntax level, you'll have misspelled names. You'll have unmatched delimiters like unmatched parentheses. Inappropriate use of infix. All the time I make the bug of having two equal signs when there should be only one, or vice versa. That's kind of a design bug in JavaScript, actually, that they're so similar in appearance yet so different in semantics. Dots and commas, they're easy to miss. And the longer the piece of code that you have that has some syntactic bug is, the harder it is to find that bug. So there's another argument for modularity in the syntax alone. Now when we move into the semantics, a lot of low-level stuff in the semantics. Most of your bugs are going to be either syntax or low-level semantics. Something's undefined, you got the wrong type, it's out of range, you're off by one, especially being off by 0 or 1 in an array reference, let's say. You might have a wrong directory, bad user interface, that can create all kinds of bugs. Lousy documentation. I worry a lot about documentation in DDE, and if there's a mismatch between the documentation and the behavior, I consider that a bug, whether or not the real problem is in the doc or the code. And lastly, the large one is wrong algorithm. And we're not going to talk about algorithms this time, but yes, of course, it's good to have good algorithms. But those are largely for that core piece of code. And then most of your code has to do with user interface stuff, and that's not so directly related to algorithms. That's more the framework and the libraries, the widget libraries you're using. Okay. So I just listed a whole ton of different types of bugs, but I don't expect you to remember them. What I will tell you, though, is that you will learn them because they will come up so often. So just be aware that there are a set of them, and when a bug shows up, remember how you solved it, because it'll probably happen again. Okay, now I want to move into specific techniques within DDE. I am going to share the screen. And okay, let's get into DDE. Oh, you know what? I want to restart DDE here. Okay, so I'm going to start by inserting this item off the Learn.js menu called JavaScript example. Sort of a larger example, well, not really large, but just half a screen of code or so, and will help us understand certain of the issues within debugging. Okay, first thing I want you to notice is over on the left bar, there's this red mark. Oh, something bad. What does it say? Unexpected identifier. And you can see if you look over to this line 4 here, we see it's underlining of. All right, well, what's that all about? Well, it turns out that a relatively new feature of JavaScript is using the word of. It means essentially here, B is an array, and we're going to be getting successively out of each iteration, each element off the array and binding it to item. Okay, that's what of does. Because it's a new feature, it hasn't yet been incorporated into this version of this lint checker that I'm using. And so it's telling me that there's an error. So there's not really an error here. And you'll find this in DDE. A lot of times these are not correct, but they're a clue. And you should take a look at them just to see. And you'll get used to the ones that are not correct. I'm slowly making them a little better, but that takes time. Okay. So one thing we can do is option click on function here, and this highlights the whole expression. So this tells us that this entire expression is basically good. It says it's ending in a square bracket, I mean a curly bracket. That's what a function should be ending in. If I click on that guy, I see the matching one up at the top here in green, right? And I can wander around, click on other ones, like here's the for loop. Oh no, that's the if. Okay, could have been a mistake. Where's the for loop? Let's go down one. Oh yeah, that's the one with the for loop. We can click on parens, see the green, you know, open and close matching parens there. Same thing in a function call, right? So clicking around can give you click help. And if we look down here, like I just clicked on out, we can see out. Like I can click on, see the documentation for out, right? In the doc pane over here. So just clicking around and option clicking around can give you a pretty good sense of, is the syntax in good shape and where do I need to add parens, etc. All right, now here's a function call. So let's take a look at this guy. Not in the release version that I just mentioned, but in the next release version, you'll be able to option click on any function call and have it highlight the whole thing. So here's another test. Does this function call look like in good shape? Yeah, it looks like it's in pretty good shape. You know, I can check the balance of these guys. In fact, let's just evaluate those guys, right? So I can evaluate those guys, click on eval and see an array. Okay, so that's good. Like already, oh, one of the hardest arguments in my function call looks like it's intact. So that looks good. I can do the same thing for my string in case I care. Yep, we got a real string. Okay, that looks good. Okay, now we're ready to call the whole function. Okay, ready? I hit eval and boom, reference error, foo is not defined at line 13. Okay, well, got the line number right. Doesn't always. You have to be careful in debugging in general, and sometimes in DE this line number is wrong, but often it's in the neighborhood. Okay, so what's the problem? Foo is not defined. Foo is not defined? What are you talking about? I got my function definition right here. All right, let's double click on foo directly and eval it. So it should be bound to the function definition. What happens when I eval? Same error, reference error, foo is not defined. Okay, now I'm starting to believe it that foo is not defined. What's this bug all about? I just forgot to define foo, right? I just forgot to click eval on this guy. Okay, so that's a really common bug right there. You'll see it all the time. Click on eval, and now, unfortunately, JavaScript has a function definition return undefined, kind of confusing in this scenario, but in any case, when I click on foo, click help says foo is the name of a function with parameters AB. Okay, AB, that sounds sort of right. And if I like, I can double click on this, you know, whole foo, and now when I hit that, I see function. Oh, good, it's no longer undefined. And in case I want to look at it, I can do the twist down there and see the actual code, but it's the same as the code that is up there. Okay, so now we finally got our function defined. Well, let's see what the heck happens. Let's click the whole expression and call eval. And gee, looks like it worked. It returned 4. So we're kind of in good shape here. Just check my notes here. All right, now, one of the things, if we look at this code, we'll see we've got some out statements. So out statements, print statements. It's like the oldest debugging trick in the book. You put in a print statement and you just see what's going on. So what's its first one? Foo called with A equals, and then we've got A. Okay, well, where the heck is that in our output pane? Ah, here it is. Foo called with A equals hello. Okay, that looks good because hello was passed in as A. This is the first argument. We're kind of verifying that A got into the function correctly, and that's all looking great. Okay, we've got a few other output statements down here, and they come from this guy. Out, got a big one, item. Okay, well, big one what? Well, big one, whatever item's value is, and we can see what happened. Got a big one, 10, got a big one, 20. Okay, that's pretty good. You know, we're kind of confident that our code is working. We're seeing our output lengths. We're getting a return value that seems reasonable. So that's all good. But let's play around a little more with this. Let's see. One of the things I can do is just comment out stuff. So commenting out just gets rid of junk that you might not want to see, and it's a great debugging technique. Okay, I've just redefined foo, and I click on this guy. I hit eval, and did it work? Well, you can see our outputs are only the got a big ones, and we no longer have this foo called with a hello, so our commenting out worked, okay? Not that that's so important in this case, but actually debugging code that you know works is a great way to learn debugging. So this exercise is not quite so stupid, even though it's sort of pointless. If you really had working code, you wouldn't do it. Okay, I want to use a heavier hammer here. So this time I'm going to go to the Insert JS menu, Debugging, and I am going to click on this debugger. Okay, now there's two versions of debugger here. One of them, the one with the semicolon at the end, is the general JavaScript one. This double quote one is something you can insert in as a instruction on a do list. We'll talk about that towards the end of this webinar. Let's do this first one, okay? Tooltip. Inserts a breakpoint in any JS code. Click right and choose Inspect to enable stepping. Okay, so we've inserted debugger here, got an extra line, let me remove that. And now we need to have our Chrome development tools up. So we click right on the output pane and we click on Inspect Insert. Okay, it's a kind of a pointless name, but basically what it does is bring up the Chrome development tools. All right, what do we got here? Well, we got a bunch of junk here. Looks like HTML. That's actually the HTML, the page of DDE that we're looking at. And we've got effectively a JavaScript listener in here. So I can type in numbers, 1 plus, here, let's see, 1 plus 2, hit return 3. Okay, now this functionality that we just got, that's very similar to this functionality here, right? 1 plus 2. Little snippets of code that you want to test. And this is just great. You just got little tiny things like that. And you're not sure of what would happen. Gee, can I pass another, can I concatenate that all together, right? Yep, it works. Test stuff all the time. Sometimes I'm not sure how a function works. It's easier for me to test it and see its result than it is to look up the documentation, and that's just fine. Okay. So this is similar to what we've already got in DDE, but in case you're suspicious and DDE is broken or something, you can come in here and do that same stuff. All right, now there's other stuff besides the console here. I click on this source tab. I'm actually now have a view into the source code of DDE. So these are all the files in DDE. These are all the files you can see in GitHub. This is not the only place you can, we're open source here. But anyway, you can click on a file and look at its stuff. You can also set breakpoints in here. Now, since we're not debugging DDE, we can't, we don't really want to set a breakpoint in DDE, but you could. And if you knew where a function was in DDE, you can find it. Anyway, the point of setting this up is that when we're going to run this function foo with debugger in it, it will only actually break. It will only actually go into the debugger if we have already initiated this window, got this window is up and showing. Otherwise, we close this window, just ignore the debugger. Okay, so let us reeval this guy with debugger in there. And now I'm going to call it again. Okay, so what happens? Boom, we get paused in debugger. Okay, that's good. Now, I can just click this arrow and proceed, and it'll just continue. But I don't really want to do that. I want to debug. So let's do some debugging. So let's do that again. Hit eval. We're pausing the debugger. Now we click on this window behind here, our Chrome development tools, and what do we get? We get this little window of the source code of our function. See, function foo ab debugger, and it's highlighting debugger, which is where that expression is. All right, now what can we do with this guy? Well, we can move my screen around. We can step through the code. So over here on the right, there's a bunch of arrows. This blue one says just run until you get the next breakpoint, or if no breakpoint, run it all the way through. And that's the same as this blue arrow that we see up here when we are over in DDE land. This one, this kind of half circle arrow means step to the next item at the same level we're at. This means step in a level means go down inside a function call, and that means go up a level. Okay, we're just going to do this one for now, step over the next level, and what happens? We move past debugger into our out statement. Okay, so now this is just before out is called. So let's take a look back here and see what's in the output pane. Okay, it's got 4 there, right? Okay, so we're before this. Now we're going to call foo call. We're going to call our out statement. Okay, click on it, moves to the next item. What really happened? Let's take a look. We go back here and see, aha, foo called with a equals hello. Okay, so we're stepping through code. We're seeing it being executed, and it's executed just the same way that it would be executed if we weren't in the debugger, except it's one heck of a lot slower and pauses all the time and lets you look around and confirm stuff. All right, now while we're in the middle of this guy, it's worth pointing out that if we want to see the value of something, like what the heck is the value of B? I can position my mouse on top of it, and it shows me in this tooltip, oh, it's an array of 7, 10, 20, and minus 3.2, okay? I can do the same thing. And anywhere you see the variable, like here up at the top, A is equal to hello, B is equal to that. Okay, so anywhere you see the variable, position your mouse on top of it, and it will show you the current value of the variable, not the value of the variable that as it was at the point that you selected. So in case you're changing the value of a variable, this is a little bit confusing, but you know, there's just one value stored for a variable. Okay, what am I going to do? I'm going to keep stepping through this guy. So if I hit forward again, I'm now going to pull out of that array of B the first item. And what the heck is that first item? It's 7. Why is that? Because, you know, look at B, we see 7, 10. Okay, good. We're looping through the elements of the array right now. Okay, now if 7 is greater than 9.9, then we're going to call this code. Well, 7 is not greater than 9.9, so when I click, it does not go down into that code, but it goes back up to the next iteration. And let's go down one more time. Okay, this time we've got 10 is greater than 9.9. Yes, it is. So when we click, now it goes down and does the action of the if, and we've got a big one. And then when I click on that guy, and we can go over here, we'll see got our big one, 10. Okay? So that is stepping, and we can keep stepping on through the rest of this stuff if we like, or we can click, you know, to the very end and just, you know, zoom through it all with this blue button. All right, now we're down to the last possible point here. We've got a B, and we're getting the length of B. That's going to equal 4. There's a little bit of computation in the tooltip here for some simple expressions. We're going to return 4, and let's just skip through it all. And we're out down, and there we are. We're 4. Okay, so that is using the Chrome Development Tools stepper. There's some confusion about whether to call it a debugger or stepper. Stepper is more accurate. Debugger is kind of a general purpose term that could mean a lot of things, so I don't like it. But in any case, get familiar with that. Here's how you do it. Insert this debugger from this element and play with this. That's what you need to do. Hang on a second. Just get to a few notes. Okay, now I want to move on to debugging a job. So this is just generic JavaScript code up to here. Let's go and let's pick an example off our jobs menu. Dexter moving is a good one. Okay, so we've got a simple job with 2 moves here. You click eval, and we've defined our job down here in this gray button, not yet run. Click on it, runs through it. You can see a little movement over here in the stepper pane. It says when it's all done, there's the progress bar, 5 of 5. So we're done. Okay, looks like it worked okay. We got a warning message. Forget about it. This isn't important right now. All right, now, first thing to note is, well, we've only got 2 instructions in here, so why does this say 5 instructions? Oop. Running out of battery. That's a big bug. Run out of electricity. Okay, hardware bug. Okay, well, the reason is because instructions on a do list can return other instructions that then get immediately added to the do list right below them, and it does other stuff. So move all joints and move to are actually relatively high level, not very high level, but they are instructions that return other lower level instructions that help them do their bidding. So even though we've only got 2 on here, well, ultimately we get up to 5 instructions in our job. All right, now, what's the first trick we want to do? Let's use a print statement. Now, we have something very similar to out called robot.out. Let's say between moves, okay. And so this is, you can't just put a call to out on the do list, but you have a special instruction. It's very similar to out, takes all the same arguments and everything. All right, let's see what that guy does. Okay, well, so we got to reevaluate our job because we've got a new item in the do list. We've got a problem, unexpected identifier here. So I need to have a comma. We need to have commas between all elements of arrays. And this is one of those like little infix things. You got to remember your commas. Fortunately, our red bullet flagged this to us. And then when you remember, you got to have that. Okay, done that. We have to reevaluate our job every time we change it. Okay, here's J2. And let's run it. Okay, what happened? It printed this job J2 instruction ID2 robot out between moves. So this is a little more sophisticated than just a straight output statement because it gives us all this extra information about where is that output statement in our code. So this can be very useful if you have a whole bunch of output statements, a whole bunch of robot.out instructions in a job. You can easily find out where it is and you don't have to mention that stuff in the out statement. It'll just automatically tell you. Okay, that's cool. Okay, now, next trick is let's step through this guy. Ooh, how do we do that? Well, what we really want to step through here is instructions, not JavaScript expressions. So ultimately, instructions are JavaScript expressions or a high level that returns more of them. But at a certain modularity level, we just wanted to step through the instructions, not the lower level stuff. How do we do that? We click on this over in the sim pane header. We've got a pause button. So you just click on that checkbox right there. Okay. Now, when we click on J2 to restart this job, what happens is we get, we get our progress bar, but we get this extra brown text here, right? J2 paused after program counter 0 of 3, your first instruction. Okay, so it's paused on that first instruction, and it tells us what the previous instruction was and what the next one is going to be. Okay, so you need to like get a little familiar with this guy, right? It's going to be telling you where we're at in this, and now we can click go and go to the next one. When our pause button is still on. So what happened? Program counter 0 of 4. Well, not sure really, but what happened is we have added a new instruction to the list. You can see it's longer now, 0 of 4, and we can keep stepping on this guy. Okay, now we're at 1 of 4. What was our previous instruction? A0000. Okay, well, what the heck is this A00 jump? Well, okay, it turns out that move all joints makes a lower level command called, well, A. We call these A's oplets. It's just a very shorthand for a low level instruction, and it's just passing the joint angles there. Now, we might want to do something a little more clever. Here's our job. Let's refresh our job so we make sure it's up to date. So this is our job J2, and in here we have a do list. Okay, now when I expand the do list, I can see a bunch of items. In particular, look at this first one. Function, returns a function because, okay, this is what is returned by move all joints, this guy right here. And but it's, notice this twist down. Well, what's going on with that? Well, that function that is returned by this also returns some stuff to put on the do list. And here's the thing that it returns. It returns this lower level A instruction. Okay, you see how these numbers are, well, don't worry about, most of them are times and the job number and the ID of the instruction actually. But see this A right here, when I position the mouse on top of it, Well, it ought to tell me that A is move all instructions, but gee, I guess I got a bug there. But in any case, that's what it is. Okay, so we can take a look at our do list while a do list is running. When we're paused, we can see exactly what other functions have, what other top level items have returned to stick on the do list. And knowing what's going on with its do list and who has stuck what on the do list is an important part of understanding how a job works. Okay, we can close that guy up and we can keep stepping, or I can just uncheck this pause and just say go, and it'll go all the way to the end. You know, here's the output statement. You can see we got 6 of done, okay? So that is using pause to step through not JavaScript functions, but actual instructions on the do list. Powerful feature, especially when you understand that things can be added on the do list, and in conjunction with expanding the do list, and see, we can look at the final if we like, and here's all the stuff that would, well, maybe I think I have to push refresh here, and we can see all the other things on. Now, you notice this last item, this G, what's going on there? Here we go, my tooltip worked. So a G instruction is an instruction that just asks Dexter for its status. When a job is run, we first ask it for its status to kind of initialize the state that DDE knows about the robot, and at the very end we ask for its status so we can use that in debugging. So that's what G commands are done, and they're stuck on automatically by running a job. Good thing to know. Okay, now I want to shift over to a actual bug that I got from a user of DDE recently. William contributed this bug to me, and I thought it was a great bug because it was kind of a subtle bug. In order to understand it, you've got to understand what how DDE works, and so I'm going to use this example of a bug to help you debug jobs in general, not just this specific one. All right, he sent me 2 versions of a job. Both of them didn't work, but it was good that he tried some alternatives here. Okay, let's take a look at this job. What's going on in the do list? First, we have a human enter number. Okay, what's that? Well, that's a thing that, gee, I have a whole webinar on human instructions, but basically pops up a dialog box, asks the human to enter a number, and it presents this text, what's the joint angle you want? Okay, so it's asking the user, and then the user has a little number widget and they input values. Now, to William's credit, he limited those values to be just known good values. So he did a good job here. He said, I know the minimum can be no less than -90 and a maximum can no greater than 90. I'm giving an initial value of 0 and making the step size be 5. So we can, as we're clicking through the number, we get 0, 5, 10, 20, that 10, 15, 20, okay. All right. Now, the other argument to this enter instruction is a user data variable name. Okay, now what human number enter number does is when you enter correct number and you hit submit, then it's going to set the user data variable named joint1 to the value that you have selected so that other instructions can use it. Okay, what other instructions? Well, like for example, this one, function out, this user data joint. Okay, we could have used robot.out here if we wanted to, but this is fine. We've got this bound to the current job when this is run, because when a function definition is on the do list, the function is called with the current instance of the job being bound to this. So this dot user data joint 1. Okay, so that all looks pretty good. Then what do? We call move all joints, and we move just to this constant -45, 10, 10, 0, 0. Okay, that's okay. And then we've got another move all joints, and this time we're using the value in the user data. So what this job is doing is saying, ask the user for a number for joint 1 for Dexter to move to, and then move to that number, right? That's what's going on in this this job. So it's a nice little example of a job, and I think many of you may write jobs that are similar to this. I like it. That's why I wanted to choose this. Okay, let's see what's going on with this guy. Let's select this job and let's hit eval, and we get an error. Okay, Cannot read property joint of undefined. Okay, at line 8, character 55. And you notice these error messages have little twist down. You can twist down. Often these twist down don't tell you much, but sometimes they do. In this case, we said we're down in eval. So we're inside of eval.js part 2. It's an internal function, and it's going through. Here's eval button action, right? When you click on eval button, this is the function that's called eval button action. You get a little tutorial on what's happening with DDE here. And here's HTML button element on click, right? So literally what's happens is when you click on this thing, it calls the on click function, and that calls eval button action, and that calls eval js2, and all the way on up to where we get to our, didn't work. Okay, let's look at line 8. Line 8 is right here. Now these line numbers are not always accurate, so be careful, but in this case it happens to be. So what's going on? Cannot read property joint 1 of undefined. All right, well, here's joint 1, so that looks like the expression. So let's just select this guy and eval it, because after all, that is what is happening. When we eval this job, this do list is just another argument, and it's evaluating this array, and evaluating an array in source code evals all the elements in the array. So this is going to be eval. Now, another perspective you might have on a job is it's kind of like a function. In a function, you define the function and then you call it. So a job is like you define the job and then you call it by calling it start method, or usually, just clicking on this button will start it. So different than a function, though, is when you have the curly braces in a function, we saw them earlier, it doesn't attempt to eval that code when you're defining the function. It only evals it when you're calling the function. Here, it is evaling this code, but this code is returning something that finally goes on the do list. So human enter number, a call to human enter number does not go on the do list. It's whatever this returns. And this happens to return let's just do it just so we'll see what happens here. It returns an instruction.control.human enter number instance. Okay, A means this is a class and we're making an instance of it, and then here's all the values of the class, initial value, min, max, 5, right? All what's a joint angle? Okay, you can see it all in there, right? Okay, similarly, our move all joints returns something other than just a call to itself, right? It actually returns a function that's a closure that has a bunch of stuff in it. I don't care too much about what that is, but in any case, this is going to be evaled when we at define time, and we can see, we get that error. So now what's the problem here? Well, let's see. Suppose we said joint 1 is undefined. Well, how about the rest of this stuff? Let's select user this.user data. Okay, we're picking apart here. This is debugging, right? What happens there? Oh, it's undefined. Okay, so this.user data is undefined. Well, what the heck is this bound to? Let's try that. Eval. Oh, here we get an object of 1,309 properties. Okay, it's a giant thing. This is really window. This is like the global namespace of JavaScript, right? So we don't want that to be the global namespace of JavaScript. We want that to be the instance of our job. Well, at define time, there is no instance of our job. It does not exist yet. So that's the bug right there, is that we're thinking that this is going to be bound to ask and move J1, the job instance, but it has yet to be created. Okay, now to William's credit, he created a second version of this guy. So here we go. It looks pretty similar. It's all the same with human enter. We've got another output. We've got our move to, and now instead of having move all joints at top level as an instruction, he's wrapped it in a function definition. So this is good, because a function definition means, when at runtime, after we start this thing and it gets down to the level of calling this particular instruction, it's going to call that function with this as its subject, and then this will be bound. So that's good news. So now what we've got inside our function, oh, wait a minute. Let me back up. I fixed the code. This is the bug he had, so sorry. Oops, you saw something a little early. Okay. So we've got move all joints, this user data. Okay, so this looks like it's going to work. So let's try it. Okay, we eval this guy. We get our new definition here. Here's ask and move. So first of all, oh, the definition worked. Good, we're making progress here. All right, now let's click on this guy. What happens? Pops up our dialog box, just like we'd hoped to say. Joint 1, we can enter some value. See these incrementing by 5. If you like, you can type in a number so you can get higher resolution if you want. But for most purposes of what William wanted, this is good enough. Okay, we click submit, and what happens? Well, we've got a one move over here, but it didn't move twice. It did, however, complete the job, so there weren't any errors. No errors, but it didn't really do what I wanted. Let's look in our job. I'm refreshing it by clicking on this little circle arrow. And now let's take a look at our do list. Okay, now what do we want to see on our do list? Well, we see this G as the very last thing, but that's just added by the system itself. What's really happening? Well, we've got to move all joints down here. So this function is on, this function right here corresponds to this guy right here, right? So those are the same things. Whoops. But we notice that there's no twist down arrow on this function. So what we really want is for Dexter move all joints to return something that goes onto the do list, and then that thing is the thing that finally causes Dexter to move. So the bug here is kind of subtle. The subtle bug is that we didn't have a return, and that's what I deleted from you seeing earlier. So that's what we need to do to fix this function, and we found it because, well, look at this long chain of events. It was, first of all, this was wrong, and then even though this was right down here, we didn't return the function. Let's just run our guide just to make sure we got it right. Okay, select the whole thing. We've got to re-eval again because we've edited the guy. This now is gray because it's never been run. We pop up our dialog box, change the value a little bit, submit. We're getting a pause there. Now, second move over there. Okay, so we've fixed our bug. That's a pretty interesting bug. We might also use the stepper on this kind of bug, clicking this pause button over here. That's the core of what I want to say on debugging techniques. Now, I have just a few more things to talk about in debugging. First of all, mostly we've been talking about implementation bugs, but there are design bugs, or what I'd say, unexpected behavior from doing stuff that's not what you think would happen, or maybe it's just confusing to a user, right? So what's an example of this? Well, I hope you can see my whole screen here. I'm on a Macintosh. Let's see. And what at the very top bar, the menu bar in a Macintosh, this is the latest version of the operating system, we have what looks like a clock face. Okay, and I look at this icon and think clock face, it's probably going to let me set the time or maybe the time zone, something like that. I don't know. So I position my mouse on this icon, which I can't figure out exactly what it's doing, but it's hard to write an icon that can really tell you exactly. And I'm expecting a tooltip. No tooltip. Oh, that's not so good. Okay, well, maybe it does the right thing anyway. Let me click on it. Oh, okay, I get a menu. All right, what do I see in the menu? Okay, so we've got this clock thing, and I see skip this backup. This backup, does this have something to do with backing up files, maybe? Maybe that's what it has to do with. But then I look at this other item, enter time machine. Enter time machine. Okay, well, that sort of makes sense with the clock face. But what is time machine? Like H.G. Wells or something? Does that have something to do with back? Well, maybe. I don't know. What else we got? Open time machine preferences. Okay, well, gee, that's sort of generally put on a menu item that has an application named time machine. So I guess I've got an application named time machine here. Well, let's see. Let me enter time machine. What's the worst that could happen? I could go back to the 1950s. I don't know. Okay. So I click on this guy, and what happens? The screen changes completely. And I look like I'm watching a movie here. I mean, there's not even a title bar. There's no menu bar. There's no like name of the application I'm in. Where am I? You know? And so this is what I call a design bug. The icon didn't help me understand what it was doing. When I finally clicked on something that I hoped was right, it sent me into outer space here. And now I'm in this thing that has no name for the program, no help button. And what have I got down here? I've got a cancel button, and I've got something grayed out. Okay, it's so grayed out, can't even read the text. That's a bug in user interface design, a classic one. But in any case, if you're careful, you can see it says restore. Okay, restore. Well, that kind of sounds like a backup program that maybe didn't get some stuff, and at least I could cancel it. Now, what I've got over here? Oh, look at this. Oh, this is a very nice widget. Look, I slide my mouse, and it says the dates come out all animated and really great. But what does it actually do? Well, I don't really know. Okay, so so what we've got here. So let me click the cancel button. What happens? It goes and it shows me the desktop. That's weird. Why did it do that? That's not where I left. Anyway, I consider Time Machine a big design bug on Apple's part. Now, to Apple's credit, they have recognized that it is an important feature of an operating system to have a backup system. I really like the fact that the backup is included in the OS. And I also like the fact that they thought it was so important that they dedicated a lot of programmer resources to it. You know, doing all that fancy animation stuff, I'm sure they had their designers in there, and there was some implementation work there. The problem is that they didn't direct it to helping the user. They just made it look good, you know, so it would be like an impressive demo. But, you know, when you're backing stuff up, you really want to be sure that you're backing up. You don't want, you know, a nice picture to hang on a wall. You want functionality. Okay, so to kind of summarize here, there really is no substitute for understanding your code. You got to understand your code, but a debugger in stepping through your code can help you understand the code. You want to look carefully at your variable names. It's really good to name them well so you know what they are when you go back to look at them in 6 months. Same thing for functions and parameters. Be consistent with yourself. If you use a name one place, try to use exactly the same spelling elsewhere, like even local variables in 2 different functions. They mean the same thing. Spell them exactly the same way. Even though they're literally distinct from the computer standpoint, it will help you know that this refers to the same kind of thing. Comment your code. You know, if it's a little tricky and you understand it now, then comment it so next time you go back and read it in a few months, you can quickly get up to speed. Another crucial point to debugging is understanding how eval works. And I gave a webinar, oh, I don't know, several weeks ago, and it was about how to think like a computer. So if you go up to the articles section here in the upper right pane, you'll see how to think like a computer. So this helps you run the evaluator in your head. As you're reading the code, what would eval do if I were evaling this code? And then you can think about, it's probably going to return this, and then that's going to be an argument to something else. And so that's what how to think like a computer is really about. You can read the article or watch the webinar. They're both roughly the same. Read the documentation for the functions that you're calling. You know, there might be something in there that helps you understand what's going on. And speaking of understanding, I have developed a new paradigm for this webinar called Understand by Design. What do you think this function really ought to do? And one of the key steps in that is, what does this function need to do its work? What inputs does it need, or what global variable data does it need to have access to in order to calculate what is supposed to be calculating? So that's understanding by design. Do a little bit of design, and then that will help you think about the algorithm and what's going on, and oftentimes that can help you localize a bug. Okay, I want to show one more thing here and close this guy up. How are you going to remember all the junk that I told you? Well, you're not. But if you type in debug and hit return or the find button, you'll see that, well, debug is actually used in a lot of places. I want to go down to the one in the user guide because that's actually the most useful one. And then within the user guide, you can see down near the bottom, we've got a whole section called debugging. Expand that. And a lot of the stuff that I covered in this webinar is down here in this debugging section. So take a look at that when you forget what I've said, and you'll be in good shape on debugging. The last thing I want to mention in this webinar is testing is an important part. Now, we talked about testing by selecting some text and hitting a val, and that's a good kind of testing, but you also is a good idea to write some actual formal tests, and then you can rerun them quickly and verify that you haven't introduced a bug by some recent code that you've written. But that is a whole nother, that is the topic of a whole nother webinar, so we'll save that for the future. Okay, happy debugging.